My name is Khalid Moose. I'm a PM on the Azure Compute team. I've been at Microsoft about 7 years. The session will be about how to use Docker and container technology for your development and application deployments. In this session, we'll cover the container technology, especially using Docker, how you can deploy your applications using containers, what problems this will help you solve, especially if you're a developer, an IT pro, and we'll also go over some demos to show you how you can use it, and especially on the Azure platform. The main thing is how you can use containers, and Docker containers specifically on Azure platform. To support it, you could do it. I have a 4-year-old daughter who thinks that I know everything. She loves to play with me, so I spend a lot of time with her outside work.
And we're rolling right along. If you're watching the live stream here on channel9.msdn.com, or if you're watching this in replay mode, you didn't notice that we had a little bit of a delay, but you know, it's always fun trying to work in extra people and extra resources and having a good time with this one here. I'm Rick Claus. This is Level Up Azure IaaS for IT pros, and in this particular session, we're going to be covering some technology that maybe a lot of you don't even know exist, or maybe have heard the term before. It's called containerization technologies, and this one we're going to be looking at is Docker as one example of containerization. So we got to kind of level set and kind of explain what they are and how they all kind of work first, and then we actually got some really cool demos lined up as well. So you saw Khalid earlier in a little bit of a video, and there's Khalid here to be able to go off and talk with us, but you also brought someone with you. Who'd you bring with us?
This is Ahmed. He's a software engineer in our team, in Azure Compute team. And he's joining me for demonstrate some of the demos we're doing today.
Fantastic. So, you know what? I'm going to get out of the way. And why don't you go ahead and just let us figure out what exactly you're going to be covering so far?
Oh, sure. Thanks, Rick. So the agenda really is we're going to talk about some of the challenges the enterprise IT managing distributed applications. We're going to talk about some of the benefits of using containerization to automate some of the processes, and then we'll talk about Docker specifically. We'll do a lot of demos on that, and then we'll show those demos and explain how to use it and how to take advantage of the technology.
Cool.
So first is the world has changed from many years ago, where we had a couple of frameworks that dominate the IT industry, but right now, as you observe, we have a lot of languages that we have to deal with, from C++, Python, Java, C#, et cetera. We have a bunch of frameworks that exist, such as .NET, Rails on Ruby, PHP, and so on. And in addition to that, we have an explosion of data platforms that exist, from SQL to NoSQL, and the list goes on. In addition to that, we have a bunch of infrastructures and cloud providers out there. So, to build these applications and stitch them together, it's really a challenge. To build once and run everywhere is not very easy. So, what do? When you stitch these applications together, you need to build them and run them, and you need to make sure they work from one environment to another. And, when you have these complex systems, it's not always, easy. To deploy them from test environments to production and what have you, and share those applications in a large scale. So what do? We have the concept of containerization. This is actually borrowed from the shipping industry, where we have a lot of goods basically that we're trying to transport from one place to another. The standard containers is what have been used in the shipping industry, so we're borrowing that in our IT platforms to take advantage of that, and have a standard way to package applications and then distribute them to different environments, different cloud services or cloud providers and hardware, etc. So that's really the how we're planning to solve this problem and make it easy for you to move your applications around and share them.
This is obviously something that's industry-wide, right? This
That's
phenomenon
correct.
we're facing right now.
That's correct.
So it's not just us that's trying to do this. This
That's
is
correct.
everybody. All the cloud providers, all the different
That's correct.
framework providers are trying to work with a more lean and mean kind of fashion. that's out
Absolutely,
there.
absolutely.
Okay.
And Azure is specifically has embraced this, and we are trying to make it easy for everybody. But you're not. The advantage here, you're not tied into a particular platform. You build once, and then you have the flexibility to move around.
Oh, okay.
So that's really what we're trying to achieve with this.
Cool.
So let's now talk about what is a container behind the scenes. I showed a blue box there, but in software terms, the closest thing we can compare it to is what people are probably very familiar with is VMs or virtual machines. So if we look at a virtual machine stack that I'm showing here to the left, what you have is you have a hardware, a server on the bottom here. Then you have a kind of host OS running on that server, and then you have hypervisor that is managing these VMs and help you to run these VMs. But these VMs typically are a full copy of an operating system. So you have a guest OS VM, and then you have a bunch of libraries and shared binaries and so on. And then you have applications that run on top of those. So that's kind of how the model works with virtual machines on pretty much any platform at this point. But you have a full copy of the operating system that you're running on on the host. So to boot up these VMs, it does take time because you have to kind of get the whole operating system up and running. When you move to containers, we changed the stack slightly. If you look at the right, we still have a hardware, which is the main server running. Then we have the host OS running on that server. But instead of having the hypervisor, what we have is the Docker daemon that is running. And that is the one that's going to provide us the abstraction and the management layer to manage these containers. As you can see here, the next level up, I don't have a full copy of the operating system anymore. And that's the main difference here. So what I'm doing, or what we are doing with this, is we are actually sharing the kernel among these containers that are running. So what the advantage of this is I don't have a full copy of the operating system, which means it's much faster to run these containers, to put them up and then to turn them down. It's a lot faster than putting up a whole operating system. So that is really the main difference and how it works in the container world. And then you run these applications on these containers, and then the Docker layer, daemon layer, is helping you to manage those containers. And we'll take a deeper look into how actually they look behind the scenes and how we actually use Docker to take care of these containers and build applications on top of them. So what's the benefits? So for developers, this means we can get going very quickly. There are currently thousands of hub images that are published in the community that people can use to get going and start running their applications. They don't have to build it from scratch. There is already a community of stuff. You can build things from scratch if you would like to, but most people are probably going to get going by taking, for example, a bare OS image and then start installing, applications on it, and then building software, their application on top of that. So that's one of the big advantages. I can get going very quickly without a lot of effort. I don't have to worry a whole lot about dependencies. That's another great advantage because the Docker layer is providing all the hooks that I need, and then because it's standard, then I can basically not have to worry about all these dependencies that, while I'm building my application, I look for this package or that package. Flexibility and portability is a huge benefit in this environment. I can easily, pull down images, install what I need, scratch them off, move them from one place to another, which is a huge benefit for developers. If I want to get going quickly, download an image. We will showcase all of these. Download an image, get stuff installed, do my application development, tear it down or move it, and share it. So that's really the key benefit. For IT pros, portability obviously is a huge benefit, especially when you're talking about production systems. Many times, one of the challenges we have is we are looking at doing deployments and testing, things working, and then when we start moving things to production, then issues start, to arise. And then, mainly they are like environment-specific issues or dependencies, and so this will help us move applications that we developed once from one environment to another in an easy way, and we will showcase some of that. You can also incorporate some of the DevOps applications that already exist today. I believe Condana has drilled down into the DevOps options using, for example, Chef, Puppets, and Vagrant, and some other DevOps application on how you can automate. And we will show a case at the end of this session how you do some of the automation to create images and so on. Fast scale out. I think the next session by Song will talk about scale out in general. We'll give a little flavor here, but one of the huge benefits of containerization in general is you can quickly tear up and down lots of containers. If you try to do that with VMs, it's not as fast. So you're talking, we're reducing from minutes of creating VMs to milliseconds of creating containers, which is a huge benefit, especially when we're talking about a large number of these virtualized applications. Areas of additional investments. This is an area that is still ongoing, and I think this is fairly new technology, so there is lots of development still happening. Mainly containers has been around for many years, but only recently, probably another in a year or maybe two. That's when it really became maybe abandoned and available with the open source community behind it, especially with Docker building the ecosystem, which we'll talk about. It became much easier to consume and use. So additional areas I mentioned here is kind of security and monitoring, and then especially on the multi-container orchestration. So if you're building applications, usually you have multi-tier, and then you need to stitch and connect these containers together. So those are some of the the areas that we will see a lot of improvement coming up in the future.
Now, I just again want to mention to people that if you do have any kind of questions around containerization technology, we're going to be showing some Docker stuff in just a minute. If you're watching this live, underneath the main player, there is an area there where you can go ahead and ask some questions on the forum. One actually came in that actually is relevant to this slide here. This came in from, looks like Glennie Boeing. I can't pronounce the Twitter handle, but it's a nice hash of a name. Basically, it's just asking, just from a technology perspective, what about things because we're not talking about a full VM when we're talking about a container. We're talking about this chunk of stuff that is basically contains the app and the logic of what's going on that's deployed on top of this layer on Azure. What happens if that thing has a memory leak or has some kind of a problem? Is that possible that it's going to go off and affect other containers that are on there? Or is there like sandboxing and isolation that's between these things, but still allows some kind of communication between them too? That
is a great question. In fact, the way you can have these containers talk to each other, currently in the Docker environment, you have to open an public IP port for these containers to talk to each other. So these processes or applications running, they are really isolated, as you mentioned, in a sandbox. That's kind of how it works.
Okay, so it's same kind of thing also applies. They don't have access to shared memory anywhere else. You've got complete isolation going on.
That's correct.
So you've got your security inside each of those individual containers.
That's correct. And this is security hardening is an area that is still evolving in this, because we are sharing the kernel, but the application itself is running in isolation.
Okay, very, very cool. If you have time,
since
I've got you here, take a look at one of these guys. Steven's got one there, or Pascal. I'll let you pick which one you want to.
So there is a question on the screen here. What about attack surface with Docker? How would the container be secure? So I think, as we talked, earlier, the hardening of the of the security of the Docker layer is in progress. But currently they are running, as I mentioned earlier. The containers cannot talk to each other without having to open a public port.
Okay,
so that's one of the way to.
So similar in idea and concept form of having, you've got your firewall hardened up that's up there. You've got to have an IP address and a port to be able to talk to you between those two containers.
That's correct.
That are out there, just like you would with a traditional type of
that's correct.
server that's there. But you're just missing that middle layer of stuff, which is the fat, if you will, that doesn't need to be there for the OS and the other stuff that's
Absolutely.
in there. Yep. How about Pascal? Can Docker apps communicate with a normal Windows application?
So, Microsoft has announced support for containerization on Windows, on the next version of the Windows Server. This is work in progress.
Right.
There is development still happening in this area. We're going to learn more about this in future.
No problem.
From a high level, there will be containers that run on Windows, and there will be containers that today run on Linux.
Yeah.
So that's kind of how.
And also, if we're talking just from an application layer perspective, as long as it has the port and knows how to communicate through that port over TCP, because it's going to be using a public IP address, then obviously, yeah, they can communicate.
Absolutely.
Right? Very, very simple. So
just separate applications, different.
Yeah.
That's the whole idea.
Okay.
And actually, that's a great point. I just want to mention the key benefits of this too is, as I showed in the first slide, is how heterogeneous these systems are. So we're talking about Windows, and we'll talk about the environment where we are actually doing development in more detail. We're talking about a lot of heterogeneous systems. I'm using different frameworks, different architectures, different like physical hardware and what have you.
very, very cool stuff.
Okay, so let's get now deeper into some of the Docker terminology so we can actually understand the ecosystem of Docker better. So I'll just introduce these, and then we'll talk how we stitch them together, and then we'll show them in the actual demos. So Docker client is a user interface that we will actually use. This is actually the most visible part that as a user you will be interfacing with to connect to the next, which is the Docker daemon, which is the actual host server that is running all these containers that we are building. Then we have the Docker Hub, and this is actually a very key component in the ecosystem. This is so when we deal with containers, at the end of the day, what we do is we want to share them around. These applications, we want to move them around. The way we move them around is through images. And these images can be shared through Docker Hub, which is kind of public, place where people can just publish their images, and then we'll talk in more detail about the categories of images. But Docker Hub is a service that is available. You can go there and see what's available, what services are available, and they are public, and anybody can go and contribute to it. Then we have the actual containers, and this is what we've been talking about. This is the virtualized piece that is running on the host. Then we have Docker images, what I just mentioned. Those are the stuff we're going to be moving around. And then we have Docker file that will help us, and we have a demo on that, to automate the image creation from these containers. So let's now talk about actually how we stitch these together. So I'm a user here to the left top corner. I've got a Docker client. This would be like my machine. It could be a Windows machine, Mac, whatever, what have you. Then you have the host machine. This is the key piece that is running the Docker daemon. And then in this machine, I have the actual containers. There could be any number of these containers that the Docker daemon is managing. Then we connect. The client makes requests to the host, and then the host does the management based on the client requests. And then if it's image related, we need to pull new images that we want to build, base our applications on. We pull them from the Docker Hub, which I mentioned earlier. If I build something I'm happy to share with the community, then I can go ahead and push it. Okay. Now this is optional. Obviously, if you're doing some development, you probably have some source control repo. So your client is connecting to that, and then as we will talk about later, if you're building these make files to do the automation, you can have them source controlled, and then you use them to build your application and push the images in an automated way. Okay,
so as an example for container A or container B, that could be like a customized WordPress thing that's running, and then you have container B as some kind of a database app in the back end or something like that.
That's correct.
You can basically bring those down. You have access to the code that basically defines what that particular container is, and that's where you'd use the source control if you want to tweak it internal to your project that you're running, or project, whatever. Then that way you make sure that you have a consistent flavor. You got multiple devs that are working on it. As the IT pro person, then when it's time to deploy, you simply say, here's the current version, deploy, go, and up it goes.
That's it. That's how it works. Yep.
Good.
Exactly. All right, demos. So let's actually see some of this in action. So I'll switch my screen here. We'll start with some basics. So I have a client here.
Before you go any further, I need you to change from extended mode to duplicate mode on your screen resolution. Of
course.
Here. Windows key P will do that. And then just wait a second, and I'll see if it works on the back side. And there we go. Good.
Great. Okay, so
just wanted to dismiss that. They're going. Perfect.
All right. So so this is a right now I'm making it simple because I'm running only one laptop. I don't have a both laptop and the so I'm showing the client and the host in one thing. but I'm running these commands here. So I'll type, for example, just Docker. This will just give me the list of commands that are available that I can use. And there's very nice kind of help system. I can do Docker version to see the version of my client, and this shows me 1.01, and then what Go version it's been built, and etc. and some references. If I want to see the version of the server, I do Docker info, and I get kind of system information. I can get an idea of what actually I'm running on the host in this case. So I have a bunch of containers. I've got 36 containers, 50 images. As you can see, like a large set of. This is not a huge VM that I'm running. By the way, just to go back a little bit, what I'm running, just to give some context of my environment, I've got a Windows machine running Windows 8.1, and I've got a VM running on Azure and running Docker host. And I'll demonstrate how you can create that VM. Then obviously, that VM is running on Azure infrastructure, running on top of some Windows server, and then obviously I can connect to my Docker Hub, which I'll talk about.
Okay, so you've
later.
already, with this particular terminal session, you've already gone in and authenticated to Azure. You've already gone in and authenticated to the machine ahead of this time. And again, we've covered that kind of stuff in the previous couple of sessions anyway.
Correct.
So you're already into the part where you're
That's
just
correct.
interfacing directly on the machine.
That's correct.
Okay.
And actually, very simple. I think it's important to note to create a VM on Azure. You can do it through CLI. I believe Madden has went through this in very detail, but fairly easy. We support this naturally. Basically, just type Azure VM Docker create. You give it the port that you want to open, and then the image from the gallery that we support, and then you give username and password. And then all you have to do is, run it. It takes a couple of minutes, and then the VM will be created, and you'll be able to manage it through the portal or, through the commandlet CLI. And I believe a lot of details has been provided this morning on how to use Azure CLI and, the portal managing. So it's already happening right now. It doesn't take that long. And then at some point when it gives me the return back, it does some validation, basically just checking if the cloud service exists, is there any duplication of the cloud service, et cetera, storage accounts, and so on. Once it's good to go and the command looks good, then I will get notice that the VM is being created, and then I can go to the portal and start managing it. And maybe just a second or more, and then it should come back telling me that the VM is being created. Obviously, so I just got the OK. Now I can go to the portal, and I can just kind of refresh, and I'll see that my VM should be in a running, or let's see, what do they call that? Oh, we need to do a quick refresh to see it, and then I'll see it in being provisioned. So if I go to the virtual machines and the portal, should refresh in just a second. Then the VM, here we go, it's starting. So I can see it here. It will take a few minutes. I don't want to spend time to wait for the VM to come back. But I do have already cooked one, the one that I'm using right now. It's been created through the exact same process. Okay, so what happens behind the scenes?
So we've got the Azure Infrastructure Service running, and then we've got a very lightweight VM that has the Docker guts already inside of it, already installed, is what you just provisioned. Exactly. And then on top of that, you'll be runing the different containers.
Exactly. Okay. And then we'll also create images based on those containers.
Okay, got it.
So I went through some of the kind of basic commands on how to do Docker info. This will give you like some of the basic stuff, kind of space that I have in this host and some other and version numbers of the actual server. So in this case, I'm running let's see, the version 3. Let's see, was supposed to be 36 kernel. This is a kernel version, and pool name. So I'm trying to look for the actual the version of the Docker. Should I expect it to be here somewhere?
It's in the previous command. If you run sudo docker version.
Yeah. Oh, right here. There. Yeah, I got it here.
Because
that's the one. Yep. So anyway, so now what I can do is I can do. Let's see what these images that I'm running here. I can just do sudo docker, and then I do images, and then I can see all the images that I'm running. So I got 50 of these. This gives you some basic information. which repository it came from, what is the tag of the image or the name of the image, and then the image ID, when it was created, and then kind of the size of the image, kind of basic information about the image. Now what I can do is I can also see, let's say I do Docker, and then I do PS, and I want to see all my containers that I'm running on this machine. I got a lot of them. I think it was like 50 or something. So I got a lot of these containers. So this is how you kind of just get a kind of feel of how you do images and containers. Now what I can say, look, I want to start a new project, if you will, and I want to download a new image from the gallery in Docker Hub, and I'll quickly show Docker Hub just to get a view of the service. If you go here, you log into Docker Hub, then what you see is basically a search of, give you a search option to search for images that you're looking for. Docker supports a bunch of official repositories that are kind of signed by them, if you will. These are blessed by Docker. These are special images. These are some of the key ones. But you can search for any image. Let's say I look for MySQL image, for example. I see a bunch of them. The first one is, is something that Docker has built, but all the rest of them are community built. So anybody could push, one or more of these images. So let's take a look, for example, at the official one, just to browse this, get an idea. So I can see here some basic information. I can see the tags, and then here it says it's official. So we know this is something I can actually. It's officially built by by Docker.
Oh, okay.
If I want to use something that is kind of open source, I can, for example, go to MySQL again. It would pop up. I'll pick the second one. The second one is slightly different. Well, what you will see in the second one is it's got an additional tab. It says Docker file. Now, what does that mean? It means that this image has been built through some kind of automation, which we will demonstrate later. But it tells you how it was built and how MySQL got into it. So you can kind of validate that it's actually kind of an image that you're looking for, that it has the version that you're looking for and stuff like that. So that's, I think, is pretty cool. And the other thing you could use is option. You can see the number of downloads. You can see the number of stars. So that's going to give you a feel of, how much can you trust this image, because this is really community. Anybody can push any image they want. If I look at, let's say, something that is not really defined, I created one kind of dummy one here. Let's just say this image. It has really nothing. You have no information what it is. Somebody, in this case it's me, created this image, but really didn't put anything. So you have no idea how much can you trust it. I don't know.
I don't think I trust it further than I could throw it.
That's right. So anyway, so that's the idea. No worries. So anyway, so that's the cool thing about this service. So anyway, you could do the exact same thing. I can go here and I can do Docker. I can do search, and I can specify. I don't want to spend time doing like a lot of these big images, but I'll just do some of mine. Same thing that I did on the portal. I can see it here, and I can see my images, for example, from the commandlets. So let's move on to some other topics. Let's look at, so we looked at how you search. Let's look at images that we have, and then look at history of some image. So for example, it's Docker, let's see, images. And then let me pick, I'll just pick, for example, this demo 2. So let's do Docker history. And then this will tell me the history of this image and how it was created. So think about these images as layers, and one layer builds on top of the other. So the way it works is this image gets started with this base image. And then this was like 17 months ago. It was created from nothing, and then 6 weeks later, or 6 weeks ago, some more stuff got added to it, and then more stuff got added to it until like 4 days ago. Some more stuff got added to it. Okay. So that's kind of how this gives you an idea how these images are being built. It's not very different from kind of how the latest kind of source control systems work. Basically, we're just building layers on top of layers. And that's very powerful. And what you'll see later, once you build new images and you try to push them, you're not pushing the whole image again. What you're pushing is the new layers, and that saves you lots of time on deploying these images. So what it does is it checks what's already in the repository. If your base image is already there, it's not going to try to upload it again, which will reduce your time to upload and share these images.
Okay.
Let's take a look again onto. Let's play with some of these images and maybe create some containers so we can see how we can use these containers. So let's do sudo docker, and then I'll run. Let's run this image in interactive mode, for example, just to see what how does it look like. So I can do the same thing. So let's see. Did I pick? Let's see. Should I want the image name? Oh, I think I want the image name used. Run interactive. So let's take a look at 2. Oops, that's not what I was looking for.
You need to add bash to the end.
What's that?
You need to add bash to the end.
Oh, that's what I was missing.
Yes.
Yeah. So because I was just running. Yeah, here we go. So thank you. So I'm inside this image now. It's basically it's a container that got created from this image, and I've got a whole machine, if you will. So I'm actually running from my client to a VM on Azure to inside a container. So that container is running now, and I can do whatever I want here. I can install new applications. I can deploy whatever I want. When I'm done, I can exit, and I am back to my host. What I'm running. So let's do some more stuff. Let's, for example, pull a base image. I'll take this one, and I think it's sudo demo. Oh, let's do mine. One. So now what I'm doing is I'm actually grabbing a copy of the image that I had, in the repository that I pushed probably from another machine. Now it's in this machine, and then what I'll do is I'll try to install something on it, something fun. So basically, I just run that image. I want to add a new layer. This is what I'm adding, more application. I'm just picking up, Figlets. It's kind of fancy way to print text and stuff like that. Let's see, sudo, sudo docker. Why not find? Oh, I misspelled this. Sorry.
Oh no.
Oh, sudo. What is it?
I guess it's complaining because of the second sudo.
Oh, did I do 2? Sudo docker run. Oh, I see. Got it. I think I didn't like this one. Technically, I can just run that. Oh.
You can directly run it on Ubuntu if you like.
Yeah, I think you could do the same because I have Ubuntu as well.
Yeah.
It could be any application. I've been making several changes to this particular demo. So Ubuntu app. And unable to find the image locally. So anyways, it's trying to grab it. Anyway, so what it's doing now is it tried to find it locally. It didn't find it because I deleted it before the demo. So it's going to try to download, which is great. It just looks for it for you. You don't have to do a lot of work. Unfortunately, this will take a little more time because that Ubuntu image is a little bigger. I think it's about 200 meg or something like that. So it will download it to my client machine. And not only that, it will crack it up open. It will add a new layer because I'm installing the Figlets application on top of it. So that's what's gonna happen next. I'm gonna let it run a little bit, but I want to showcase one more thing. I want to create a container, and I want to make some changes to it. And I'm gonna commit it, and I'm gonna create an image, and then I'm gonna push that image. So let's go through that process. So let's do this. It's almost done, but then. I think I know why, because of the Figlet for that particular version does not exist. But let's create, for example, this container. So I'll do like my job, something like this. So I'll define a job to let me take a look at this. So this is just defining an environment, or like a variable, and then I'm gonna do a Docker logs. This will just confirm that it's running. Obviously, copy paste. So what this job is doing, as we can see from this command, it's basically just running a batch and doing a while loop, and then it's just printing some text, and then sleeping for a capture. Basically, I'm just trying to create a kind of long-running process, so it actually show. So when I do the log, it actually goes inside that job and telling me it's actually doing some stuff. So every 2 seconds, it's printing, the word Docker in this case. Then what I want to do is I say, oh, I like this. Let me look at the jobs running. Let's see if the container is actually running. So if I do this, I can see that this is the container I just created. I can go and do Docker attach to this container. And then I'm inside that container now, as you can see. So basically what I did is I got a base image. I created this long-running process, run it as a container, and I can log into that inside that container as if it's a regular machine. I can see it running, and then I can exit from this. And then what I'll do, I'll snap in an image. I'll say, let me commit this change. Now I like it. My software is ready. I'm going to commit this change. I'm going to push an image. So what I'll do next is I will go Docker restarts, because I did Control C, which actually kind of stops the container. So I need to restart it. So I'll do restarts, and then I'll do sudo docker, and I want to do run commits, and then I do the container. So when this commits, what will happen is I get an image name. Now I have an image that I can actually share. So, but what I will do is, obviously I don't want to, let's do a quickly inspect, so just to get an idea before we actually push it. So we do Docker, and then we do images. Then I should see that image, which was, D0, which is this one. Okay, if I do actually no, let's see, no truncate, then I should see the whole image. This is probably not very, so that's the first one. But this name is very long, not very friendly. So what I want to do, I want to tag it as a name that people can reference, and that's what we'll show in the Docker Hub gallery. So I will do sudo Docker, and then I'll do tag, and then I'll give it the image name, and then I'll call it something like my username, and then slash, let's call it Azure Week, demo, some number. So now this is tagged. I can do same thing I did earlier. I can see that image now has been renamed to this.
Oh, okay.
Now what I'll do is I'll take that image. Now it's still in my local box. I want to push it up to the Azure gallery. So what I'll do is sudo Docker, and then I'll do push, and then I'll take the name, which in this case was Azure Week Demo 10. Now it's taking that image and pushing it to the gallery, to the Docker Hub. And then I can give it a few seconds. Shouldn't take that long. And the interesting thing, as I mentioned earlier, is that you'll see it will cross-check. If the base image has already been existing in the gallery, it's not going to try to push it itself. It's only going to push the layer.
There's an extra layer on top of that. Okay, so we had a question to come up on Twitter that was a little bit later on, a little while ago. It was looking for the differences between Docker containers, Docker images, and the overall host. So the image is simply a modified version of a container that you put layers on top of. The container is essentially the same thing, just a different terminology that you're using. It's the technology that's basically the image is inside of. And then you've got the host, which is the underlying platform, which is running the Docker containerization technology on top of it. Did I get that right?
So it's like container is mostly like the running version of an image.
Okay.
While it's running, we call it a container.
Okay.
While it's not running, it's an image.
Okay.
Yeah.
Got it.
Yep.
And then obviously the host is simply the technology that's running someplace
Yeah.
that the Docker solution is on top of.
That's right.
That you then have the containers that are running on top of that as well.
That's
That's
right.
correct.
Okay.
That's right.
I think I'm getting it.
That's
I
right.
think I'm getting it.
Yes, it is. You know, a little
it's
tricky,
new. They-
especially we're running a virtual machine on Azure on a cloud, and then that virtual machine in this case is the host.
Okay. And,
But that VM is running on a host by itself.
and to step
still-
back just a little
yeah.
bit, once again, all of these types of containers, all these containers are portable to run on any solution
That's correct.
anywhere.
That's
So
correct.
Azure supports it. It could also work on something like AWS.
That's right.
It could work on other cloud providers as
And that's
well,
the
or even
beauty-
in-house as well.
Absolutely, and
Okay.
that's the beauty of this.
Okay.
As long as I'm running Docker, I can move these containers anywhere I want.
Mm-hmm.
By the way, the image just finished, uploading. As you can see, it already did a bunch of skipping because it said, "Oh, this, my base images that I built on
Mm-hmm.
already exist. I'm not going to push them." It took only like a few seconds.
Okay.
So I can go now to the gallery. I don't know. Typically it takes just a couple of seconds, and it will show up as my one of my images that I just pushed. And this is public; anybody can go and look it up. And then I'll go here and I'll type, this, and then you'll see here the Azure Demo 10 that I just created.
okay.
So that's kind of how it works. So I started from a base image, I installed some software. In this case, a long-running process. I attached to that process so I can see it's actually working okay. I snapped an image from that. I committed it. I snapped an image from that, and then I pushed the image to the gallery.
Okay.
So that's kind of the flow we just demonstrated. So I want to switch context a little bit just to show this layering. If I go here before we switch to the next set of demos. So this is basically how it works. We have, in the host, we have the, as I showed in the previous diagram, this is kind of the image layering. You've got the kernel and the boot file system, and then you have the base image. And the base image could be just a plain operating system. It could be a Ubuntu or a CentOS, whatever you like to run. And then on top of that, you're installing additional layers, more applications, more applications. That's kind of the view. I just want to explain, make sure it's very important because that's really how it works, and it's very important to understand this concept. So quickly moving on to next set of demos. Let's do now maybe we'll demonstrate a diff. So this next set of demo, what I want to show is I'll go into a container, I'll make some changes, and then I'll commit those changes. Then I want to see the diff of what I did, because many times you want to keep track of what you did. You've been doing some development, you want to change something in the file system, you want to see how those changes has been reflected. So let's just quickly do this. So I'll do sudo docker, and then I'll run interactive. I'll get a TTY, and then in this case, let's say I'll pick this demo 1. So as you can see, this just run this in interactive mode. So demo 1 basically is just saying hello, kind of application.
We still have the same problem with the demo being on non-extended mode because of the PowerPoint switching back. So just Windows P once again.
Got it.
There we go.
Yep, thank you. So I just logged into this to this container. It's running a log running process. What I want to do inside this container is I want to change something in the file system. So what I'll do is I'll take a look at do Docker, and then I'll do a diff, and I see that, for example, there's a file inside that container that I added. In this case, I added a hello file, and then I changed something in the batch history. That's going to just tell me what changed in this container.
Cool.
That's just want to show that. Quickly, we'll do a quick scale out. We're not going to spend a lot of time, and then I want to leave time for the automation. So we'll quickly just do. If I have to create many containers, how would it work? How long it's going to take? So in this case, let's say I just want to go and create, I don't know, let's say 20 containers. Okay, Put this to 20. Basically, what this is just looping and creating a bunch of containers, and I'm running like a long running process on them. So I'll just go here and batch scale, and then you'll see how fast these containers can be created. As I mentioned earlier, the main advantage of this is to make deployments faster. And as you can see here, I'm already created 3 containers, and it's ongoing, and it should finish within seconds. I'm creating 20 containers. These are like 20 machines.
So it's spinning these up on the spot.
Exactly.
Okay, so this is definitely something to highlight here. If we were doing a multi-tier application using traditional VMs, and you needed to scale that up and out, you'd be looking at minutes or more per VM to come up.
That's right.
And then it would also take configuration time of that VM to ensure that it was talking correctly to all the different pieces, and then go. So if there was like a 15 or 20 different VM environment, it could easily take half an hour or so to get it all spun up.
At least, yes.
And you just hit 19 right now.
20. I just did all 20, just finished before you finished talking.
Okay.
So just
now I'm seeing some value here.
That's right.
For what this makes sense for.
This is all good, but as you can see, I've been doing a lot of manual work. I've been copying commands, and even I've been making mistakes.
It looks pretty prone to errors.
Very
offense,
hard.
No offense. But some of your demos, you had some errors in there.
Exactly. So what we want to do now is, there is actually a better way to do this.
Okay.
There is automation, which Ahmed is going to spend time to explain how you can do it. Because this is really painful. Even with all these commandlets we have and stuff like that, it's still, when I'm doing a scale application, it's very difficult. I mean, I forgot some commands. It's very painful. I can't keep them up. I have my one note, and I still made mistakes. So now let's turn it to Ahmed and explain how you can actually automate this whole thing. If I want to build like a scale application, how do I automate it? Ahmed.
Hi folks, Ahmet Balkan, software engineer at Microsoft Azure Compute. So if we have switched to my display right now, you can see that I'm right now running on a Mac, and this Mac is connected to my VM running Linux on Azure. So what you'll see in a minute, that I will be running some containers on a Linux VM on Azure on which we are running Docker. And on my Mac right now, so I have this page, ASP.NET on GitHub. What I'm going to show is how can I run an ASP.NET application, how can I create an image out of it, and how can I scale out, basically. So in my browser right now, you'll see that we have an ASP.NET repository here. By the way, for those who don't know, ASP.NET is right now open source, and ASP.NET 5 will be able to run cross-platform. Like you can run ASP.NET on your Mac, on your Linux, or on your Windows. So I will go to the samples directory, and here you will see that there is an Hello Web, Hello MVC, and console application. We'll just pick the Hello Web application. And in fact, I have this repository checked in locally on my machine, so I'm switching to my terminal. And as you can see that I have the Hello Web directory here. So simply, I'm going to explain what exactly is going on inside this directory. So let's look at the startup CS file now. So as you can see, it's like a 10-line web application. It's just going to show us some hello world, no big deal. And then I will switch to the project.json file. And here we have some dependencies listed for the web application, and there is a set of commands. For example, we'll be running Kestrel, and the Kestrel web server is going to start listening at port 5004 right now. And then we have something called Docker file. This is what Khalid was mentioning earlier. This Docker file is like a make file. It contains the instructions to build a Docker image out of your application. So if you look at this Docker file right now, what I have here is, in the first line, I have a statement saying from Microsoft/ASP.NET. So if I go back to my browser again, in the Docker hub, we have an official image that's for ASP.NET 5. So this is in preview stage. Don't expect it to be running like perfectly, but it's not recommended for production usage yet. So you can basically download this ASP.NET image to your Docker host by just running docker pull Microsoft ASP.NET command, on the top right. So if I want to use that image as a base image in my application, I can just say from Microsoft ASP.NET, and I will start layering the following commands on top of this application. So in the next line, I'm running copy./app. So what this does is, I'm going to copy what's in this directory to the containers/app directory. and I will go into that /app directory, and I will be running a command called kpm restore. This is an ASP.NET command, and this command is going to download the dependencies that are required for the application. And at the last line, you'll see that I have an entry point. So this is what will be invoked when I log into my, when actually my container is going to run. So this entry point is kkestrel. It is going to start a web server, and it will start listening and on port 5004. So I'm going to quit this, and let's see what I have here. I'm going to just run docker ps. So you can see that no applications, no containers are running on my Docker host right now, and I will just run Docker images. So as you can see, I have a Microsoft ASP.NET image. It is like 473 megabytes. And let's actually build this Docker file. Let's make it turn into an image. So I'm going to execute a command called docker build, and I will execute it right in this folder, but I'm going to take this image as my app. So if I run this command, you'll see that each step is executed, like copy, worker, run, entry point. All these steps are executed serially, and then I have an application image right now. So if I run Docker images again, you will see that my app is right here, and it is like 499 megabytes. Of course, this is why we downloaded the dependencies, we added our application. That's why there is a size difference between the Microsoft ASP.NET application and my app. So let's actually make a container out of this image. So I'm going to run a command called docker run. This will start the container. So basically what I'm going to do is I'm going to run it in the background, and I'm going to map port 80 of my VM to the port 5004 of my container. So, and I'll just use the image name my app. So when I run this command, if I run docker ps again to see what's running, I can see that, okay, the same ID, a container with the same ID is executed, and like it's up for last 3 seconds, and I did the port mapping from port 80 of the local machine to the 5004 of the container. And if I go to my browser right now, if I go to this page, port 80, I will see that an ASP.NET application is right now running on Linux inside a Docker container. And I did all these from my Mac. I can do the same thing from my Linux, from my Windows machine. That doesn't matter. So let's actually start another container listening at port 81. So I'm going to just go ahead and switch the port mapping from 81 to 5004. I will just create the same container. It will be the exact same container, except the port mapping difference. So I will run another container, and as you can see, it came up very quickly, like within less than a second maybe. So I'm going to run the command docker ps again to see what's going on. As you can see, I have another container here. It just came up, and it is running the same command kkestrel. So let's go back to the browser and see if this one is running. So I can go to port 81 and see that it is also running. So it is very easy to, as you can see, package your application, send it to cloud, and get it up and running.
Wow.
Multiple instances.
Yeah, you can scale as much as you want. As Khalid showed before, creating containers are just a safe way to have your application isolated in a smaller system that is not VM. It doesn't have the same high memory footprint, high disk footprint. You know, the images, if I have a Microsoft ASP.NET image on my machine, that image like takes, as I showed you before in the Docker images command, it takes 473 megabytes. And whatever I build on top of it, they are going to be diffs on top of that application. So if I have 100 applications, different applications using the Microsoft ASP.NET as a base image, these all are going to be stored as diffs on your VM. So it doesn't have high disk footprint as well for your VM.
So from bringing this back down to the IT Pro audience that's on here that are used to virtualization side of things, someone actually asked on Twitter, what are the advantages of using Docker? These Docker containers, and like you just mentioned there, it's like it's extremely lightweight. It can basically run anywhere it needs to run, wherever your provider, be it Azure, be it AWS, be it your on-premises environment, wherever Docker has been implemented, it can run on those environments. And it is also something that's been around for, you're saying, for about a couple of years now?
More than a year.
And so more than a year, and so obviously it has a community of people that are building these different
right.
containers for people to use and modify.
them.
And so obviously we're showing you some very simple demos right now. There's, as you mentioned at the very beginning, there's thousands of containers that already exist that are supported by the Docker community and even made by third parties that are supported by those third parties, or that are community built as well.
Correct.
And you can use these to piece together inside your project to make them work on top of Azure.
If you don't have to build something from scratch, why do it? Just build on something that people has already built.
Definitely.
And also share if something you built to the community, and that's the whole idea of this ecosystem. I know we're just a little bit running out of time, but I just want to quickly show, if we switch to my screen, we also support the
to go back into your duplicate mode once again.
Got it, sorry. So
There
we
you go.
support, recently we have announced support for Docker client for Windows machine. So now you have the option to use the Docker client in your Windows machine.
Oh, okay.
So that's been announced a couple of weeks ago.
Yep.
It looks exactly the same. This is actually my Docker client that I'm showing here. It's you're running it. You basically get the exact same experience.
Okay. So you can make your images, you can layer them, you can pull them
exactly.
down,
I can
you
do
push
exactly
them
what
up.
I've showed earlier. I can do the same thing. I can try to log in, for example, and then it will allow me to. So same experience that we have that I showed in the Linux option.
Wow.
To wrap up, I just want to summarize some of the key points. So, in summary, this environment or this ecosystem will standardize application packaging for you. You can get more for your old hardware. I mean, as you can see, I just put up 20 containers in a few seconds in a VM. That already had a bunch of other containers already running. I think I had 50 or so, and then a bunch of images already running on it. So I'm actually running a bunch of applications in the same VM, and then we're condensing as much as I can, taking out as much of the resources that we already have. It's easy, as you mentioned earlier, and we talked about earlier, is how to basically move these applications. We just demonstrated how you can create, download a base image, create a container, install a bunch of your applications on it, snap another image, and push it, and then share it. So you see how easy, and I can go to another machine and download that image. Anybody can, in fact, download that image, so you could go and try it out. It's a lightweight virtualization. The key here is speed. It's very agile, very speed. We're not taking a full copy of the operating system. We're only taking pieces that we need from the shared kernel. So that's really why we're getting all these. So we just demonstrated earlier how you can boot up these containers, as Ahmed mentioned earlier, very quickly. We're talking about seconds or milliseconds. We can run multiple of these copies of the same, and Ahmed has demonstrated that. And that's actually really pain point if you if you try to do this otherwise. It's very difficult to run multiple instances. You run into like config conflicts and stuff like that. He's just done it. He did two, but he could do any number really, as long as he changes the port numbers and so on. And then obviously what this means for you, the IT Pro, is really cost savings. You could take advantage of this technology and deploy your applications and share them, and you remove that pain that we used to have before, where I am debugging all these environment specific issues. So that's kind of the main benefits.
Very, very cool. Thank you very much for taking the time to come down. I'm glad that we were able to get this Docker session into this particular week. I was very, very stressed about trying to make sure that it fit inside their timelines, everything else like that, because I think this is important technology that as IT professionals and sysadmins and LAN admins that we need to know about and how to use them, that sort of stuff, and not fear them, if you will. So thank you very much for coming down. And
thank you very
the
much.
time.
Thank you,
I
Rick.
appreciate it. And also, last minute edition, good to see you.
Thank
Had
you.
some great comments about the guy on the back end there with the Mac talking about Linux and sort of stuff. So yes, we play well with others and that sort of
That's
stuff.
right.
At Microsoft. We'll be coming right back after the break and talking about some large-scale Linux deployments and how to handle large-scale Linux deployments on the Azure platform. So join us after the break, and if you're watching this on replay mode, don't worry about it. You can just hit the next video on the line.